Okay, so the best way to go over doing this is to actually just do one. So this is kind of just your steps side by side, and then I did the steps in line with a problem, but you're going to have a couple different types of problems. So you're going to have ones that are going to have linear factors. Okay, this is a linear factor. You're going to have repeated linear factors where something is squared. And then you're going to have quadratic factors. So we're going to look at all three of those. So let's look at this first example where we are going to have linear fractions, or linear factors. So in the whole process to getting partial fractions, you do the start of long division because it's the remainder after you do long division. A lot of your problems on the homework and then on your test will just have you start on step 3 or step 2, where it's already divided and you're just going through the whole decomposition phase. So we're going to do the whole thing now. So we're going to do the long division of this problem. So if I'm doing the long division of this problem, I'm setting up my numerator, or sorry, not my numerator, my divisor as x cubed. I'm missing an x squared, so plus 0x squared minus 4x plus 0. Not really necessary in this case, but definitely here when I'm doing my divisors. I have a 2x to the 4th plus 0x cubed minus 8x squared plus 5x minus 2. And actually here, we don't need the zeros on the outside, so we're going to change this. It's a little easier on us. We're going to do x cubed minus 4x. Actually, nope, just kidding. Go back. It's been a while. X cubed plus 0x squared minus 4x plus 0. Okay. All right, first step for long division, you divide first term divided by first term. So I am going to do 2x to the 4th divided by x cubed. What's that going to be in me? 2x, good. So I do my 2x, put that up here, and then I multiply. I do 2x times x cubed, put it underneath here, 2x to the 4th. Then I do 2x times 0x squared, and that gives me a 0x cubed. 2x times negative 4x will give me a negative 8x squared. And then 2x times 0 will give me a 0x. Then my next step in division is I change all my signs. Subtract, subtract, add, subtract. Okay, then this cancels, this cancels, this cancels. I bring down a 5x minus 2. Now I get to the point where if I did first term divided by first term, 5x divided by x cubed, I can't do that. Okay, so that is my remainder. So what we're looking at is a remainder of 5x minus 2 over, and now we can just write it as x cubed minus 4x. So this would be our answer, okay, previously. But now what we're going to do is we're going to break it down and decompose this. Okay, so now basically we are going to, until the very, very end, ignore this guy, this 2x. So I'm just kind of going to take a line, make a dotted line here, and I am concerned with this 5x minus 2 over x cubed minus 4x. Okay, so now we go to step 2. We're going to factor the denominator of this fraction. Okay, so here when I factor this, I can pull out a GCF of x, which would give me x squared minus 4, and then that is going to factor to what? Yeah, x plus 2, x minus 2. Okay, so this is factored. I've got 5x minus 2 over x plus 2, x minus 2. Okay, once you get to that step, now what you are going to do is you are going to find the vertical asymptotes of the denominator. Okay, so where does this become 0 or in the denominator? So that would be at x equals 0, x plus 2 equals 0, which would give us a negative 2, and x minus 2 equals 0, which would give us a positive 2. So those are our asymptotes, 0, negative 2, 2. That's what x cannot be. All right, I'm going to put those aside. Then I'm going to break this down. So I'm going to take this, and I'm going to set it up like so. And I gave you a whole piece of paper for this because these problems do take a whole piece of paper. All right, so you're going to have the beginning, the 5x minus 2, over x plus 2, x minus 2. Okay, then you're going to go equals, and you're going to do a over the first factor, which is x. Leave some space, plus b over the second factor, which is x plus 2, and then space c over the third factor, x minus 2. You do that for each linear factor. All right, now what you're going to do is you're going to get rid of the fractions. So you're going to multiply every term by the common denominator, which is just this x plus 2, x minus 2, which means every single term gets this. So we're going to write this 4 times. And I know it's a pain to write, but do it so you can follow with your notes. When you're looking back, you don't want to go, how did I go from here to here? Okay, now when I do that, give you guys a second to do that. Okay, here's what happens. This entire denominator cancels out, and I'm left with a 5x minus 2. Over here, these x's cancel, and I'm left with an a times x plus 2, x minus 2. Here, the x plus 2's are going to cancel out, and I'm left with a plus bx, and then x minus 2. Here, the x minus 2's will cancel, and I'm left with a cx, x plus 2. Okay, then what we're going to do is we're going to go to the next step, and we're going to use the asymptotes that we found in step 3, one at a time. We're going to plug those in for x. So we're going to start with x equals 0. So I'm going to plug 0 in here. I'm going to go 5 times 0. So 5 times 0 minus 2 equals a times 0 plus 2, 0 minus 2, plus b times 0, 0 minus 2, plus c times 0, 0 plus 2. Here's what ends up happening. 5 times 0 is 0, minus 2, that's negative 2. This gives me a times 2, negative 2. This is b times 0 times negative 2. That's 0. Anything times 0 is 0. Same thing here. C times 0 times positive 2, also 0. So those go away. I'm left with only one variable, which is a. So I solve for a. So that's 2 times negative 2, which is a negative 4. So I have negative 2 equals negative 4a. Divide by negative 4, and I get negative 2 over 4, which is going to give me a positive 1/2. So I get the value of a. Now we're going to do that again with the next value that we had found in step 3, negative 2. And I'm going to always be going from this line here. So I have x equals negative 2. And I'm going to go 5 times negative 2 minus 2 equals a times negative 2 plus 2, negative 2 minus 2, plus b times negative 2, negative 2 minus 2, plus c times negative 2, negative 2 plus 2. It's a lot of writing. That works out. 5 times negative 2 is negative 10. Minus 2 is going to give me a negative 12. Negative 2 plus 2 is 0. So this is a times 0 times negative 4. So the a cancels. This is going to give me a b times negative 2 times negative 4. And this is c times negative 2 times 0. Negative 2 plus 2 here. So that also cancels out. Now I can find b. So this is going to give me negative 2 times negative 4, positive 8. And I get negative 12 equals 8b. Divide by 8. And that's going to give me a negative, they both are divisible by 4. 3 over 2 equals b. So I found b. And then we're going to do it again with positive 2. So we're going to go 5 times 2 minus 2 equals a, 2 plus 2, 2 minus 2, plus b times 2, 2 minus 2, plus c times 2, 2 plus 2. Okay, and then once you guys start doing this a couple times, you'll see where it's going to come in and be 0, and you don't have to write so much. Okay, but the first couple times you do it, you do want to write that out so you can see when you go back in your notes. So we've got everything plugged in. 5 times 2 is 10, minus 2 is going to give me 8. 2 plus 2 is 4, 2 minus 2 is 0, so this is going to be 0. 2 minus 2 is 0 here, same thing. So this is c, 2 times 4. That's going to be 8c. And that's going to give me 1. So I have a is 1/2, b is negative 3 over 2, and c is 1. So how do we write the answer? I'm going to show you. You might have run out of room. Oh, we got room here. Okay. So how we're going to write the answer is like so. So remember that 2x from the beginning? You've got the 2x. And then plus, you have the a over x. Okay, so just remember what we had before. It was like this. B was over x plus 2, and c was over x minus 2. Okay, so you just put a, b, and c in. So this is 2x plus 1/2 over x, which can be written like this, 1 over 2x. Plus negative 3 over 2, so that's going to be minus, because it's a negative, it makes the whole thing negative, 3 over 2 times x plus 2, like that. And then plus c, which is 1 plus 1 over x minus And fraction is decomposed. Takes practice. Steps are a little tricky to remember. You guys ready for another one? Even if you're not, we're going to do another one. Okay. So the steps are on the previous page. Let's go ahead and do the division to start this. Like I said, a lot of the problems will already have the fraction decomposed without the division already being there. So, okay. So I've got x cubed plus 2x. I guess I'm going to have to go plus 2x squared minus 3x. I guess you could put a plus 0 here. And then we're dividing 5x to the 5th plus 10x to the 4th minus 15x cubed plus 3x squared minus 3x minus 12. Okay, so first term divided by first term is going to be 5x to the 5th over x cubed. So what does that give me? 5x squared. So I got 5x squared. I'll multiply, so 5x squared times x cubed gives me a 5x to the 5th. 5x squared times 2x squared, 5 times 2 is 10, x to the 4th. 5 times negative 3 is negative 15. Those x's are going to be x cubed. And then this is 0x squared. Change our signs. This is negative, negative, positive, negative. And these cancel, these cancel, these cancel. And I'm left here, 3x squared minus 3x minus 12. I cannot do 3x squared divided by x cubed because I'd have an x in the denominator. This is my remainder. So now I have my remainder that I want to decompose. Okay, so here is the problem I'm looking at now. I've got 5x squared and then plus my remainder, 3x squared minus 3x minus 12 over x cubed plus 2x squared minus 3x. Okay, you always know if you can decompose the fraction if the degree of the denominator is greater than the degree of the numerator. Otherwise, you would be able to divide. Okay, so now we're going to deal with the fraction. So we're just going to kind of draw an imaginary line here. Well, actually, I think I can do a dotted line on here. Just draw a line. Okay. Next step, what was the next step on there? Factor, yeah. So we can factor this. So we can pull an x out of here. It's going to give me x squared plus 2x minus 3. What's that going to factor to? X minus 1, x plus 3. Good. All right, so that is our new problem. You've got 3x squared minus 3x minus 12. Over x minus 1, x plus 3. We're going to go ahead and off to the side write down our asymptotes before we set everything up. You've got, what are our asymptotes here? Good, 0, 1, negative 3. Those are the values that cannot be in the denominator. All right, so then we're going to set this up. We've got 3 linear factors. So we're going to go equals a over x b over x minus 1, c over x plus 3. All right, so once we get a, b, and c, this is where we're plugging them in. Okay, let's go ahead and, I don't know if I have enough room there, but we'll do it anyway. Red. Okay, so now we're going to multiply out the denominators, which means everything gets multiplied by x, x minus 1, x plus 3. I'm going to write them real small. Okay, the whole thing cancels on the left. I'm left with 3x squared minus 3x minus 12. On the a, the x cancels. On the b, the x minus 1 cancels. And on the c, the x plus 3 cancels. So then I have a, x minus 1, x plus 3, plus bx, x plus 3, plus cx, x minus 1. Okay. After we get to that step, what's the next thing that we're going to do? We're going to plug these three numbers in. Okay, the asymptotes of our equation. So 0, 1, -3, one at a time for x. Okay, so let's start with 0. 3 times 0 squared minus 3 times 0 minus 12 equals a, 0 minus 1, 0 plus 3, plus b times 0, 0 plus 3, plus c times 0, 0 minus 1. Three times 0 squared, 0. 3 times 0, 0. Negative 12 will come down on the left. This is going to give me a times negative 1 times 3. B times 0 times 3 is 0. Same thing with the C. This is going to give me negative 3a equals negative 12, which gives me an a value of positive 4. All right. Next value I'm plugging in is what? Negative 1, positive 1? Positive 1. Okay, so 3 times positive 1 squared minus 3 times 1 minus 12 equals a, 1 minus 1, 1 plus 3, plus b times 1, 1 plus 3, plus c times 1, 1 minus 1. Okay, so that gives us 3 times 1 squared, 3 minus 3 minus 12, negative 12. Let's see here. 1 minus 1 is 0, so this cancels. B is going to work. You got b times 1 times 4. 1 minus 1 here is 0, so the c is going to cancel also. All right, and then 1 times 4 is 4, so this is 4b. Divide by 4, and that gives us negative 3. So I found my b. And then I got one more. What was the last one? Negative 3. Yep. All right, so 3 times negative 3 squared minus 3 times negative 3 minus 12 equals A. 3 minus 1, negative 3 plus 3, plus B times negative 3, negative 3 plus 3, and C times negative 3, negative 3 minus 1. Yeah, okay. All right, so negative 3 squared is going to be 9. So this is 3 times 9 minus, well, that would be plus 9 minus 12. So 27 plus 9, 36 minus 12, 24. 24 over there. Plus 9 looks a little weird. All right, A times negative 4 times 0, 0. B times negative 3 times 0, 0. This is going to give me C times negative 3 times negative 4. Negative 3 times negative 4 is positive 12. Divide by 12, I get 2. So I have my A, my B, and my C. So I can write my final answer. We go back up here. Okay, the A goes in over X, the B goes over X minus 1, the C goes over X plus 3. And remember that 5x squared from the beginning. So we've got 5x squared, then plus, what was it? 4. 4 over x. Okay, then negative 3 for b, so minus 3, and that was over x minus 1. And then plus 2, and that was over x plus 3. And then just be careful if you have the factors, so if you put the x plus 3 first, the 2 would still go over the x plus 3. The negative 3 would still go over the x minus 1. Okay, so not too bad because it's all algebra stuff that you guys already know how to do. It's just remembering the steps because there's a lot of steps and it takes a lot of room. So a lot of room for mistakes. Show your work. This side? That side. All right. Is there just one more? I've got some practice problems for you guys for after this. So let's do this one. And then I'll give you a practice one. So this is when you have a, what we call repeated linear factors. So the factors are still linear. There's no quadratics there. There's just 2 of them, the x minus 4s. So it's weird how you write it. All right, so this is how you're going to do this one. This is already set up as a denominator, right? So you skip step 1. It says just go ahead and decompose this fraction. You don't need to do any division there, but you can. Okay, so because this has a degree of 3, if I multiplied this out, that's a degree of 1. So I can't do that division. That's when I know to start right away. For these, this is how you're going to set them up. So you have your first factor of just x minus 4. So it's going to go a over x minus 4. And then you're going to go b, and then you're going to go x minus 4 squared. And I know that seems redundant because now there's 3x minus 4s. But that's how you're doing it. If it were x minus 4 cubed, then you would do a c x minus 4 cubed. And you're going to do that as many times until you get to this degree. Okay, so you're going to write it, if it were, let's just say it were like x to the 4th, you would have an a over x, a b over x squared, a c over x cubed, and a d over x to the 4th. So you're just going until you get to that degree. Okay. All right, so the b's goes over x minus 4 squared, and then you have to deal with the x plus 5. So then you have a c over x plus 5. Here's this. Let's go ahead and note what our asymptotes are. What do we have for those? Just 2, right? Or -5. So this is going to actually work out a little bit differently as we go through it. All right, so let's go ahead and I'm going to rewrite this and multiply out our denominators. So we've got a 3x minus 147 over x minus 4 squared, x plus 5, equals a over x minus 4 plus b over x minus 4 squared plus c over x plus 5. All right, and the denominator we're multiplying by is going to be this x minus 4 squared, x plus 5. Okay, so we don't need to add that extra 1 in when you're doing this. So x minus 4 squared, x plus 5, next to each term, we can multiply it out. All right, so on the left, they all cancel. So I left with a 3x minus 147. Okay, then on the right, for a, just one of the x minus 4s in the numerator comes out, so that's a, and then x minus 4x plus 5. And then on b, the whole x minus 4 squared will cancel. So it's going to be a b x plus 5. And then on c, the x plus 5s are going to cancel. So it's going to be c x minus 4 squared. Okay, so then next up, we start plugging our asymptotes in. So let's start with the 4. So 3 times 4 minus 147 is going to be 12 minus 147. Oh, what is that? Negative 135. Okay, then A, I'm going to get A 4 minus 4, 4 plus 5. Then I have B, 4 plus 5. And I have C, 4 minus 4 squared. All right, so over here I've got, let's see, 4 minus 4 is 0. So the A is going to get crossed out. B times 4 plus 5, so it's B times 9, so 9B. And C, 4 minus 4 is 0, 0 squared is 0. So that cancels out too. So I'm finding B. So 135 divided by 9. 15, negative 15. All right, so I got B. Okay, now let's plug our next value in, which was a negative 5. Okay, so I've got 3 times negative 5 minus 147 equals A, negative 5 minus 4, negative 5 plus 5. Then I've got B, negative 5 plus 5. And then C, negative 5 minus 4 squared. All right, so 3 times negative 5 going to be negative 15 minus 147, going to give me negative 162. Okay, then here, this negative 5 plus 5 gives me 0, so the whole A is going to cancel out. B as well, B times 0 is 0. This is going to be C times negative 9 squared, which is going to give me 81. And then I'm going to divide by 81, and that is going to give me negative 2. But now I have B and C, but I'm out of asymptotes and I still don't have A. So here's what you're going to do in this case. You are going to take this whole thing and you're going to plug your B and your C in and see what you're left with. So now you have this. 3x minus 147 equals A, x minus 4, x plus 5. And then you have B, which you know is negative 15. So minus 15, x plus 5. And then C is negative 2, so minus 2, x minus 4 squared. If the negative 15 and 2 are correct, then any arbitrary number you plug in for x will work to find A in this equation. So now what you're going to do is you're just going to pick a number for x. And don't do 1. Okay, just because, I mean, it should still work, but use like a better, bigger number than 1 when you're doing it. So give me a number. Don't say 2. What do you got? 5. Let's use 5. All right, 5 is a nice number. So we're going to plug 5 in for x. We're going to say x equals 5. And it should work with any number that you do. You should all still get the same A. You want to try it with another one. So we'll go 3 times 5 minus 147 is going to be A. 5 minus 4, 5 plus 5. Minus 15, 5 plus 5. Minus 2, 5 minus 4 squared. So let's see, that's 15 minus 147. I think that's negative 132. And then let's see, we've got A times 1 times 10. So that's going to be 10A. Minus, let's see, 15 times 10. That's going to be minus 150. Minus 2 times 1 squared. So 1 squared is 1, times 2. And then you have an algebra equation to solve for A. So negative 132 equals 10A minus 152. Add 152 to both sides. That is going to give me a positive 20. And look at that. A equals 2. Now you have A. Oh, where'd it go? There it is. Stop. There you go. Okay. Now you have A. Now you can plug it back in for A, B, and C. So you go all the way back up to the top. Just not that far. Right here for your A, B, and C. You didn't have anything in front of it because you didn't do any division in the beginning. So you're just plugging those in. So your answer is going to be A is 2 over x minus 4. B was negative 15, so minus 15 over x minus 4 squared. And then C was negative 2, so minus 2 over x plus 5. Those are the 2 types of problems with partial fractions that I'm going to put on the test. There's 3 questions on the test. 2 of them are multiple choice, 1 is the short answer. Work out. There is also nonlinear factors. Well, you have a quadratic factor, so you're gonna want it on the homework, but not on the test. Okay. But let me give you a practice one before I show you how to do that. So I know that that's it, and it probably goes to the next page. But let me give you a practice one to try this on your own. All right, and we're kind of cheating a little bit because the denominator is already factored for you. So you're just going to go straight into the decomposition. So you've got 12x squared plus 162x plus 384. Sorry about the big numbers when I make them up. Sometimes that happens. Over x plus 8, x plus 2, x plus 11. So this is like the first two problems. So you guys go ahead and work on that for a few minutes. I'm going to have a snack because I'm starving, and then we will go over it. Okay, so in doing this, you are going to initially set it up as a over x plus 8 plus b over x plus 2 plus c over x plus 11. Okay, then you have your asymptotes. What were they? Yeah, negative 8, negative 2, negative 11. Good. Okay, so we multiply everything out. 8, x plus 2, x plus 11. We did that on each of those, right? I'm just going to go through the whole thing. So that should have given you a 12x squared plus 162x plus x 384. The a, you're going to have a x plus 2, x plus 11. The b, you're going to have plus b and then x plus 8, x plus 11. And then the c, you should get x plus 8, x plus 2. The denominator is canceled from each of those. All right, when we plug the negative 8 in, here's what we've got. 12 times negative 8 squared plus 162 times negative 8 plus 384. And that's going to work in the A. Negative 8 plus 2, negative 8 plus 11. I don't need to plug it in for B and C because I already know that that's going to cancel out and it's going to be 0 for those. Okay, so I've got 12 times negative 8 squared. What's that going to give me? Yeah, 768. And then 162 times negative 8, 1296. So I've got 768 minus 1296 plus 384. And that should give me, I don't know, what was it? Negative 144? Sounds right. No, I put 786, not 768. See, I have a little bit of dyslexia sometimes. There we go, negative 144. And then this is going to be A times negative 6 and positive 3. So that is negative 18. Okay. And that was 144 divided by 18. Nice. Positive 8. All right, so we got our A. Let's go ahead and do B. Okay, so I've got 12 times negative 2 squared plus 162 times negative 2 plus 384. Negative 2 is not going to go into the A, that's going to be a 0 there. Works with the B, not going to go into the C because it's going to give you a 0 right there. So you've got B, negative 2, negative 2 plus 8. And then negative 2 plus 11. Okay, so negative 2 squared is 4, 12 times 4, 48. Help me out here, 162 times negative 2, negative 324 plus 384. And that's going to give us what? 108. Yeah. All right, and then this is B times 6 times 9. 6 times 9, 54. What's 108 divided by 54? Awesome. And it's not always going to be whole numbers. If you guys want whole numbers, sometimes you get fractions like 1/2 and stuff like that. But you're not going to get like crazy. Well, you might, but most likely not like a 23 over 41 or something. That might be a little bit off. You might want to. All right, and then the last number we're plugging in is negative 11. Okay, so 12 times negative 11 squared plus 162 times negative 11 plus 384 equals B. No, sorry. This is going to be the C. I got to go back up here and look at it. Okay, negative 11 plugged into A is going to give us a 0. B is going to give us a 0. So for C, it's going to go into C. And then negative 11 plus 8. Negative 11 plus 2. Okay, so 12 times 121. I think I've got it here. 1452. Yeah. 162 times negative 11. 1382 plus 384. And all of that, 54? Yeah, okay. And then you've got C times negative 3 times negative 9, so 27. And that's going to give you 2 again. So you have A, B, and C. So then we go back up here. 8 is A, 2 for both of those. And you're plugging it in right here for A, B, and C. So you've got, there we go, 8 over X plus 8 plus 2 over X plus 2 plus 2 over X plus 11. And there's our final answer. And there we go. Okay. And one more. I'm going to show you guys. Now, I'm not going to test you on the quadratic factors, but you are going to have one like this on your homework. I want you to be able to do it. It's a little more complicated, and it's a lot about like matching factors. So let me show you. Okay, so the problem is like this. You've got 12x plus 3, and then you're going over x minus 1, and x squared plus x plus 1. Okay, and you look at that and you say, I can't factor x squared plus x plus 1, so now that's a quadratic factor. So when you have a quadratic factor, you're going to set it up like this. You're going to have a over your linear factor. Your quadratic factor will have this, so bx plus c. So you put a linear factor over a quadratic factor because it's 1 degree less. So then this will be x squared plus x plus 1. Okay, we start off everything the same. So we multiply, well, we do our asymptotes. which in this case is just going to be a positive 1. And then you multiply all this out, which would leave you with a 12x plus 3 equals a times x squared plus x plus 1 plus bx plus c. You've got to group that, and then x minus 1 once you've multiplied out the denominators. So then we'll plug the 1 in. So that would give us 12 times 1 plus 3 equals a 1 squared plus 1 plus 1. And then this would give us 0 over here. So we can find our a. So it's going to be 15 equals a times 3. So I get a 5 for a. All right, now the next thing you're going to do is this. So you're going to take this whole thing, you're going to plug the 5 in for a. Okay, so up to this point, same steps. Now what we're going to do is we're going to take this, we're going to go 12x plus 3, and then we're going to plug the 5 in for a. And we're not going to pick something to plug in for x because we still have two different numbers. So this is a quadratic, this 5x squared and stuff like that. So you're actually going to work this out, move it to one side, and then match factors. Sounds weird. So here's how it works. So, here we go. Okay, I'm going to distribute the 5. So where'd you go? There you go. Okay, so that's going to be 12x plus 3, and that's going to equal 5x squared plus 5x plus 5. And then you got all this stuff over here. I'm just going to leave that right now. I'm going to move all this to the left. So I'm going to subtract the 5x squared, subtract the 5x, subtract the 5 over on this side. Okay, so on this side, they all cancel out. I've got a negative 5x squared. 12x minus 5x gives me a positive 7x. And 3 minus 5, negative 2. And then I can bring this down. I'm going to factor this. Okay, so I'm going to factor this. I'm going to multiply negative 5 times negative 2, which is going to give me a positive 10. Then I'm going to split this 7 into my factors of 10 that add to 7. And since these are both positive, that's actually a positive 5x and a positive 2x. Okay, bring down my negative 5x squared and my minus 2. Finish the factoring. Hopefully you guys can see where this is going now. Factor out here, I can factor out a negative 5x. And that would give me negative 5x, and then x minus 1. And then over here, I could factor out 2. And that will give me x minus 1. So then this factors to negative 5x plus 2, x minus 1, which equals bx plus c, x minus 1. So now you're just playing the matching game. Bx is this negative 5x. C is this positive 2, because they're the same thing. Look, they equal each other. C equals is the same thing as matching. So we're matching. So we say negative 5x equals bx, 2 equals c. They're the same thing because they're equal to each other. And then plug that in for bx and c. So then the final answer here would be the a, which was 5, right? Yeah, 5 over x minus 1. And then plus a negative 5x plus 2. And I'm going to keep it like that because that negative would, I don't want to distribute it to the 2. It's positive. And then over the x squared plus x plus 1. Like I said, I'm not going to put one like this on the test because it's not really part of the objectives. But you are going to have 1 or 2 homework questions like that because we like to stretch on homework a little bit. So when you come across it, this is the steps that you're going to do. All right, so test next week. The review again on Black.